Here we will analyze how Python manages the errors gracefully in the code. When something goes wrong, exception handling lets your code continue running, making the applications more robust and user-friendly. This can catch and manage runtime errors that would otherwise terminate the program. This prevents the program from unexpected stopping, creating a smoother experience for the users. It provides meaningful error messages that help user understand what went wrong, and most importantly, you can implement graceful error recovery strategies to keep the applications running even with problem occurring. Let's look at the building blocks of exceptional handling in Python. The try block is where you place the code that might raise an exception. Python will monitor this code for potential errors. The except block catches and handles the specific exception when they occur, allowing to respond appropriately. And an optional else block runs only if no exceptions were raised in the try block, creating a path for successful execution. And finally, the finally block contains cleanup operation that will always execute regardless of whether an exception occurred or not. Here, the try keyword marks the beginning of the risky code section that might raise an exception. Inside the try block, we place any code that could potentially cause errors. The except statement specifies which type of exception to catch. We can target the specific error types. And in this block, we write to handle the specific exception that was caught. And in the else block, only executes when no exceptions occur in the try block. This is where we put the code that should run only if everything in the try block worked correctly. And the finally block always execute whether an exception occurred or not. Let's explore how to handle multiple types of exceptions in a single try block. In the try block, we attempt to divide by 0, which will raise a zero division error exception. In this except block specifically catches the division by 0 errors. When this exception occurs, we display a helpful message to the user. We can also catch other exceptions like value error in the same structure. Each exception types can have its own custom error message. The final except block with exception as E acts as the catch for all other unexpected errors. Now let's examine a complete example using else and finally blocks for file operations. In this example, demonstrate the successful execution paths and proper resource cleanup. In the try block, we attempt to open a file for reading which might not exist. Then we try to read the contents of the file. If the file doesn't exist, this except block will catch the file not found error. We provide a clear message to indicate the file could not be found. The else block only executes if the file was successfully opened and read. And we confirm the success message to user if everything worked correctly. The finally block contains our cleanup code. Here we ensure the file is closed regardless of whether an exception occurred or not. This prevents the resource leakage. Python provides comprehensive error handling capabilities with specific and generic exception catching. The else block separates error handling from successful execution, while finally blocks ensures proper resource management. By mastering the exception handling, you will create more robust applications that gracefully respond to unexpected situations.